Okay, quick update here. I am making additional progress on my secondary board here. As a reminder, I've pretty much validated most of the hardware on my primary board. I want this 265 to kind of be the master of the system, in charge of the overall system. And I'd like the secondary to use its 265 to control video and audio. And that video, the VGA out, I validated that worked fine in the last video. The only thing I really have left on this primary board is my real-time clock and my SD card reader and the VIA that's associated with those, but I'm not too worried about that. I've been using the VIA for other stuff. I know it works. It's really now just accessing these two little devices, which won't be a big deal. What I've done since the last video where I had validated the VGA output is I have populated the rest of this board with these 3 chips for the audio, and I'm going to talk through those real briefly in this video. I've also put in a power on self-test for the secondary static RAM. So I've got that 512K chip that is being tested on startup. And then I'm also testing this secondary flash ROM on startup through a post. And what I'll do is I'll record this boot up, but now I have audible cues that are either going to beep with an upward shift in tone if these pass, or that it's going to shift in a downward, so it's going to go to a lower note if these were to fail. And not a real big deal on there, but just if you hear that in the power on self-test, that is now me testing these and using this little piezoelectric to indicate if those are passing or failing. And then I'm going to output from these to this line out over here. The one thing I do have to test yet from this board, that's really, I think, the last thing left, is I'll have to connect these and from the secondary validate that I can test and see this dual port static RAM that is shared between the two microcontrollers. But that's a different video for another day when I get into parallel interface bus again, and I'm going to leave that for now then. And what I am going to do is boot this up and do my best to record this. So I have a little microphone here that I'm going to try to pick up the piezoelectric the best I can. And I've also plugged in from this line out a little splitter that goes to some earbuds so that I can kind of monitor what's coming out. But then also I'm running this into a USB capture for audio on my PC. And so what I want to do here is I'm going to really turn on the recording of this line out into the rest of my audio. And in addition, I'll have this separate recording from this microphone that I can overlay in the editing. But I'm going to turn on the system, and what you're going to hear is my power on beeps that I know I've got power to the board. You're going to hear some tones that indicate this static RAM passes, this flash ROM passes, and then you are going to hear some audio out here. And what I'm going to do on startup is I'm going to basically play a note out of one of these 3 channels on one of the programmable sound generators. And then I'm going to add a second note and a third note and a fourth and a fifth and a sixth note. So there's going to be 6 notes playing simultaneously, just to let me validate that I'm controlling all 6 and that they're building in the audio. And then I'll play a little like a Windows Start type of sound, which only uses a few channels instead of all 6, but at least something just to kind of test that that's playing okay. Okay, so I'm going to unmute and start recording this here, and also I'm recording that, and I will turn on the system here. Okay, I've remuted the output here coming into my OBS that I'm recording with, so that is no longer making any noise here. But what you heard, hopefully, and I'll go back and see this in the edit, hopefully, but that you heard the piezoelectric for my post type of stuff, the turn on, later status updates, the testing of these things. And then you also heard this line out and me testing those 6 channels out of these 2 programmable sound generators. And I'm still doing all the video output and all of that stuff. So maybe I'll jump over to my Easy EDA for a moment and just point out this really the audio schematic portion of this is pretty simple. I have a versatile interface adapter, and that allows my 265 microcontroller to use it to basically then control these 2 programmable sound generators. And I happen to be using the YM2149s. And they have a couple of signals to do some signaling of what am I trying to read, am I trying to write, what am I trying to do with them, so that I can set different port values. And then it has data ports. It has a byte coming into each of these that I can then write or read. So I can write configuration, I can read information back. And as I write that configuration, it's then going to generate 3 analog signals per chip. So I've got 6 that all come together. They get routed over here out through this connector right here. And the schematic is pretty straightforward. So if I go to the actual, what does this look like? This is it in its entirety. So there's the VIA, the versatile interface adapter over here. And I'm using 1 port from it for the common data bus between these 3 chips. I then also have 4 pins where I'm going to control some of these signals called BDIR and BC. And I've got a pair of those signals for each of these programmable sound generators. And so between those signals, along with the data lines right here that I'm running to these down here, that's giving me access to control them. And then these data lines here are what are going over to my actual microcontroller. And then there's some addressing to actually control the versatile interface adapter. But then the output, these 6 outputs, so I have my PSG0, I have channel ABC, PSG1, ABC. Those are all tied together. They're run through a little electrolytic capacitor to that line out with a little 330 ohm pull to ground at that point. I have a 2 megahertz oscillator, and that oscillator is providing a clock to these programmable sound generators. You can run 2 different speed clocks depending on how you configure it. I'm running the 2 megahertz configuration. And that's really it for this. And that's already in the schematic that I've posted previously, if you want to look at that in a little bit more detail. Maybe in addition to that, real briefly, I'm not going to get too far into this today because I think I'll have additional videos after I do some refactoring and cleanup. I did bring in a sound assembly file from an older project, stripped it down a little bit, did a little bit of a modification to make it fit this project. But I have a routine in here to initialize my sound. I have an a routine in here that I can also come in and have it do things like play that series of test chords, the 6 on the startup. And then also I have a routine to play the Windows Start sound. You know, in the basics of these PSGs is that I need to, toggle certain control bits, and those are basically built into some of these other routines that I have to support this. So there's a set registers. I can come in here and I can say, well, if I want to play some test chords, I can tell it basically here is a pointer to some tune. And I have a tune here called sound reset. And so in this case, what happens is if I come down, I have this sound reset. And it basically is telling it the data that I'm going to read through. I'm going to go out and find register 0, and I'm going to write a 0 to it. I'm going to write to register 1 this value. And I'm going to repeat that all the way down. And so that sequence is basically resetting a PSG, a programmable sound generator. Well, then I've got other sequences. For example, I have a sequence maybe to play a B6 flat. And to do that, I'm going to go out to 2 of the registers and set the frequency. There's a coarse and a fine. Maybe think of it as a high byte, low byte. And then there's a volume. And then I have a little tag to say I'm done with this sequence. And if I want, I can then say, okay, after I'm done doing a reset, by playing that reset tune to both PSGs. Then I want to play an F6, and I want to play that on PSG 0. Then I want to play a D6, and I want to play that on PSG 0. And then an A5 on 0. And then I play a G5 on PSG 1. In other words, the other PSG. And then after I do the G5, I do an E5 and a C5. So all of those, I'm just accumulating those outputs that are all going to combine together when I do this. And then at the end, I play a tune that basically turns off all the sound. And all those different things is just playing the right sequence that sets the right registers. And I have a routine called play tune that just simply runs through those and sets them accordingly. So if I come up here as an example, I can basically see this code that takes that pointer to the tune and then runs through it, reads the register number and then the value. It writes it out using write data that I have, and then you have to do some latching and such. I have a longer video from a while back that really goes through this in detail, so I'm not going to go through it in detail here. If you're interested in that, go back to that video. I'll put a link in the YouTube chat or comments, I guess, and see if I can put it here on the screen too if it's not too long. But that'd be a good place to go back to. And I'm going to work on this quite a bit here moving forward. So you might see some updated videos. I have things like, instead of just hard coding it like that, I do have a play from ROM. And this basically can go out to a ROM and read the whole sequence of a song in the format that I've kind of standardized on, and basically play an entire song just from a blob of data in a ROM chip. Or I can go to an SD card through SPI. And so those are two ways I've read song data and played it back in the past. Not the main focus for this video. The main focus is just, though, to kind of recap that I have this board over here. It is up and running. Here's my VIA. Here's a PSG and a PSG. Those 6 channels are being combined and sent out over here. Here's the capacitor. The resistor for that I think I might have underneath on the bottom side of the board. But basically that is what I'm doing here, and that all appears to be working. So that's all I wanted to share real quick on this video. Look for future ones, though. I now know I can build off of that, so I can start working on better audio. I'll probably get some 6-channel songs set up and kind of test out how well this can play back. And then I need to get my other board connected and get my dual port static RAM between them just validated, and then I can just start building out audio and video, operating system, all of that. I can just kind of keep working on week by week and do quite a bit, I think, with this hardware that is now appearing to be in pretty good order. So that's it for this. Probably one of the shorter videos I do, but hopefully that just provides a quick update that audio is working and my secondary flash is working, my secondary static RAM is working, and I'm down to just a handful of hardware things yet to do or to validate.